In today's session, we are going to discuss about the distance formula. The distance formula is useful to find the distance between any two given points. So let me state the distance formula and then let me prove it. If I have 2 points, so suppose I have 2 points, the points are A of x1, y1 and the point B is x2, y2. So here I would say that x1 is the abscissa of point A or the x coordinate of point A. So abscissa of A, and x2 is the abscissa of B. Abscissa of a point is basically the x coordinate of that particular point. Y1 is the y coordinate of the point, so it is called the ordinate. So this is the ordinate of A, and y2 is the ordinate of point B, right? So now if these are the 2 points, then the distance between point A, B, or distance between A and B is nothing but the length of AB, and this length is given by the under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So the distance between any 2 points with coordinates x1, y1 and x2, y2 is given by root of x2 minus x1 the whole square plus y2 minus y1 the whole square. I can also write this as under root of x1 minus x2 the whole square plus y1 minus y2 the whole square, right? So because there is a squaring operation that is happening, even if you get a negative answer for x2 minus x1 or y2 minus y1, it doesn't matter. The squaring operation makes all the numbers positive, and this is how you can find the distance between any 2 points, right? So now let us go ahead and prove this particular formula. Let me draw the coordinate axis. So I know that the horizontal axis is called the x-axis and the vertical axis is called the y-axis. Let's assume that I have a point A over here. So let us assume that this is A of x1, y1, right? And let there be another point which is B of x2, y2. Now I wish to find the distance between points A and B. That is, I want to find the length of AB. So what I'm first going to do is, I am first going to construct the perpendiculars to the x and y axis. So I know that if this is the perpendicular that I draw, then I know that this perpendicular distance, this vertical distance is going to be y1, right? So this particular distance is y1. And also if I project the point B onto the x-axis vertically, then this particular length, this vertical length is going to be y2, right? Because this indicates the y coordinate of the point. So let me make the markings. Similarly, if I draw a projection onto the y-axis, that is this particular length is going to be x1. This is the horizontal dimension of that point A, right? So this is going to be x1, and similarly I am going to have the horizontal dimension till this point, right? So maybe I can show it right over here. This particular distance is going to be x2. This whole distance is going to be x2, right? So now if you notice, I basically have a right angle triangle here. So if I were to shade this triangle, this is a right angle triangle. So this is a right angle triangle in which I notice that this is perpendicular, right? So there's a 90-degree angle here because the horizontal line is definitely perpendicular to the vertical line. And now if you think about the dimensions of this triangle, the whole length was y2. So this complete length is y2. This complete length is y2, right? Of which a part of it is y1. So this complete length is y2 and this length is y1, which means that this particular length BC, the length BC is going to be y2 minus y1, right? Similarly, the complete horizontal length, that is this length is x2, this complete length is x2, of which a part of the length is x1. So this length is x1, right? If I take this particular point, this length is x1 and this horizontal length is x2, which means the length AC is going to be x2 minus x1. And therefore, now this is a right angle triangle. I know the length of BC, I know the length of AC. So I can say using Pythagoras theorem, I can say that AB square is equal to AC square plus BC square. Now AB square is therefore going to be equal to AC. The length AC is x2 minus x1. So the length is x2 minus x1 the whole square plus the length BC is y2 minus y1 the whole square. And therefore, I can say that square on the left hand side would become square root on the right hand side. Therefore, the length of AB becomes under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. In short, if I were to write this in plain English, I would write it as follows. The distance between any 2 points is given by the square root of the difference in their x coordinates square plus the square of the difference in their y coordinates, right? This is how I can think about this particular formula in a very conceptual manner. So this is called the distance formula because it helps me find the distance between any 2 points. And let me explain the derivation part one more time. If I were to shade the x and y coordinates of point B, I know that the complete vertical length is y2. So let's darken it. This complete length is y2 and the complete horizontal length is x2. And if I take the points of, measurements or the coordinates of point A, then the horizontal measurement is x1 and the vertical measurement is y1, which tells me that the length BC, so I constructed a right angle triangle. So this tells me that the length BC is going to be the difference in the y coordinates because I know that this particular length is y1, right? This particular length is y1 and the complete length. So if I label this particular point, let this point be M. I know that BM is y2 and CM is y1. Therefore, the length BC is equal to y2 minus y1. Similarly, the complete length, the complete horizontal length. So XC is x2 and XA is x1. Therefore, the length AC is going to be x2 minus x1, right? And therefore, I can now use the Pythagoras theorem, and Pythagoras theorem gives me the distance as under root of x2 minus x1 the whole square, plus y2 minus y1 the whole square. So this is how I can find the distance between any 2 points given their x and y coordinates. So pausing for a minute before you take a look at this complete idea, and then we will go ahead with some more concepts. So now let us also revise some basics of coordinate geometry. So in basics of coordinate geometry, we have learned that any point on a 2D plane, this is called a Cartesian plane, by the way. So any point on a 2D Cartesian plane will be represented by its x and y coordinates. The x coordinate of a point, is basically the distance of the point, from the y-axis. So for example, if I want to plot a point, say 2, 3, okay, so let's plot a point 2, 3, then I know that the point is going to be over here. So x coordinate is 2 and y coordinate is 3. You will notice that the distance of the point from the y-axis happens to be the x coordinate, right? So this distance is 2, and the y coordinate of a point is the distance of the point from the x-axis. Now when I say that these are the distances, they are the perpendicular distances or the shortest distances, right? So this is the perpendicular distance, 2 is the perpendicular distance from y-axis. The vertical axis is called the y-axis, the horizontal axis is the x-axis. The point where these two axes meet is called the origin, and the perpendicular distance from the x-axis is basically the y coordinate. We also know that the x coordinate of a point, is also called as the abscissa of the point, and the y coordinate of a point is also known as ordinate of that particular point, right? So in this case, suppose I plot a point over here, say this is point P. I can definitely find its coordinates. The horizontal coordinate is 6, right? Horizontal coordinate is 6 and the vertical coordinate is 5. So this point is 6, 5. The abscissa of this point is 6 and the ordinate of this point is 5, right? Then the coordinate of the origin is 0, 0. So that's another important point. Origin has coordinates 0, 0. And also if you notice all the points on x-axis, so this particular point on x-axis has coordinate 1, 0. This point has coordinates 2, 0. This particular point has coordinate 3, 0. This point has coordinate 4, 0, and so on. And of course on the negative side the coordinate would be negative 1, 0. Then this point would be negative 2, 0. This point would be negative 3, 0, and so on. So one thing that we notice is all points on the x-axis will have their y coordinates equal to 0, right? And that's because the vertical height of the point from the x-axis happens to be 0. That is why the y coordinate is 0. And therefore any point on x-axis can be represented by say the coordinates x, 0. So we are sure that on the x-axis the y coordinate is 0 and x coordinate could be anything. That is why any point on the x-axis is written as x, 0. And similarly all points on the y-axis have their x coordinate equal to 0. That means you pick any point on the y-axis. So let's pick this particular point. This point has coordinates 0, 6. This point has coordinates 0, 5. This particular point has coordinates 0, 4. Similarly, this particular point will have coordinates 0, negative 2. This particular point will have coordinates 0, negative 3, and so on. And therefore, it is safe to assume that any point on y-axis will be written as 0, y, because we are sure that the x coordinate of that particular point is going to be 0. Now let's understand the meaning of the word equidistant. Okay. Now equidistant and midpoint are two different terms. Okay, let's understand the difference between them. When I say that there is a point, so let me mark a random point here. If you label this particular point as M, okay, let's label this point as M. Consider a point N which is 2 units vertically below it, and consider a point L which is 2 units to the horizontal of it. You will notice that the distance between ML and the distance between NM is equal, right? Both these distances are 2 units each. So when I say that M is equidistant, in this case I can say that M is equidistant from L and N. It just means that LM is equal to NM, right? The 3 points need not be collinear. Collinear would mean that they lie on a straight line. The 3 points need not be collinear. So N, M and L over here are non-collinear points. That means they don't lie on the same straight line. So equidistant just means distances are equal. It does not mean that the 3 points are collinear. Whereas when I talk about a midpoint, so let me draw a line. So in this case, consider this point to be L and this point to be N. When I say that M is the midpoint, it means that LM is equal to MN. Now that was happening even in case of equidistant points. But when I say that it is a midpoint, it also implies that L, M and N are in one straight line, or I can say that L, M and N are collinear points. Okay, so when I say that a point is a midpoint of other 2 points, it means that all the 3 points are collinear. So this is the difference between equidistant points and midpoints. Equidistant point just means that the distances are equal, whereas midpoint additionally means that the points need to be collinear. So these are some important concepts. I will again pause for a minute and then we will take up some more important ideas in coordinate geometry. So let us now take up some questions based on distance formula. Let us take up the first set of questions. Find the distance between the points P of 3, -5 and Q of 8, 7, right? So the points given to me are the points given to me are P of 3 comma minus 5 and Q of 8 comma 7, right? So now the length PQ is therefore going to be, let us mark 3 as x1 and 8 as x2. Let us mark y1 as minus 5. See, if I take 3 as x1, then minus 5 should be y1 and 7 is y2. So now what I need to do is, I need to find the length. So PQ is going to be the square root of difference in their x coordinates. That is, now I can either do 3 minus 8 or 8 minus 3. Anything is going to be fine. So I should first fix my order. Let me do 8 minus 3. So 8 minus 3 the whole square. Plus now I need to find the difference in their y coordinates. So I would do 7 minus of minus 5. Be very careful with the signs. 7 minus of minus 5 the whole square. So this is going to be under root of 8 minus 3 is 5. So under root of 5 square plus minus of minus 5 becomes plus 5. So 7 plus 5 becomes 12. So 12 square. And this is going to be under root of 25 plus 144, which is equal to under root of 169, and that is equal to 13 units, right? So this is the distance between the points P and Q. Now over here, you could have also taken it as 3 minus 8. So suppose you decide to find the difference between P and Q, that is also acceptable. So let us solve it with that method. So it would be 3 minus 8 the whole square, 3 minus 8 the whole square, plus minus 5 minus 7 the whole square, minus 5 minus 7 the whole square, and that is going to be under root of 3 minus 8 is negative 5. So negative 5 the whole square plus negative 5 negative 7 is negative 12 the whole square. That again becomes under root of negative 5 square is 25 and negative 12 square is 144, which is root of 169, and that is equal to 13 units, right? So this is how we can find the distance PQ if you wish to do P minus Q. Now you will notice that even though I had 5 square and 12 square in the first case, negative 5 square and negative 12 square is the same as 5 square and 12 square. That is why these signs really do not matter, and that is why whether you subtract the second point from the first point or the first from the second or second from first, it really doesn't matter. Okay, let us take up the next question. Find the distance between the points A of 2, 3 and B of 5, 7. I can say let the point A of 2, 3 be equivalent to A of x1, y1, and therefore x1 is equal to 2 and y1 is equal to 3. Similarly, let B of 5, 7 be equivalent to B of x2, y2, and therefore x2 is equal to 5 and y2 is equal to 7, and the distance between A and B is going to be AB is under root of y2 minus y1 the whole square plus x2 minus x1 the whole square, and that is under root of y2 minus y1 is 7 minus 3 the whole square plus 5 minus 2 the whole square. So this is going to be under root of 4 square plus 3 square, and that is going to be under root of 16 plus 9, which is 25, and therefore this is equal to 5 units, right? So this is how you can find the distance between A and B. Of course, you could have also done B minus A instead of A minus B, or I could have also done 2 minus 5 and 3 minus 7. That would have still given me the same answer, right? So again, pausing for a few seconds before taking up the next set of questions. Let us take up the next question. Find the distance between the points P of minus 3, 2 and Q of 5, minus 4. So I can say that let P of minus 3, 2 correspond to P of x1, y1, and this would imply x1 is negative 3 and y1 is positive 2. Similarly, let Q of 5, minus 4 correspond to Q of x2, y2, which means x2 is equal to 5 and y2 is equal to negative 4. So I know that according to the distance formula, the length PQ will be given as under root of x2 minus x1 the whole square plus y2 minus y1 the whole square, and that is going to be under root of x2 is 5 minus of minus 3, so x2 minus and x1 is negative 3. So be very careful with the signs, and y2 minus y1 is going to be minus 4 minus 2 the whole square. So this becomes under root of 5 plus 3 is 8. So this becomes 8 square plus negative 6 the whole square, which is under root of 64 plus 36, which is equal to square root of 100, and that is equal to 10 units. Therefore, the distance between points P and Q is 10 units. So let us take a look at the next question. Find the distance of the point P of 5, minus 5 from the origin. So I know that one of the points here is origin, which is 0, 0. So I will say let P of 5, minus 5 be equivalent to P of x1, y1, and let origin of 0, 0 be equivalent to Q of x2, y2. So comparing, I get x1 equals 5 and y1 equals minus 5, and x2 is 0 and y2 is also equal to 0. So I know that according to distance formula, by the way, the point should be O and not Q. So I can say that according to the distance formula, the length of OP is equal to under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That is going to be under root of x2 minus x1, that's 0 minus of 5 the whole square. So x2 is 0 and x1 is 5, plus y2 is 0 minus of minus 5 the whole square. So this becomes under root of negative 5 the whole square plus positive 5 square. That is going to be root of 25 plus 25, which is root 50, and root 50 is nothing but 5 root 2 units, right? So this is how I can compute the distance between the point and the origin. Now if you are wondering how did I convert root 50 to 5 root 2, I can write root 50 as square root of 25 times 2, and square root of 25 is 5, so therefore this becomes 5 root 2, right? So this is how I can solve this particular question, pausing for a minute before moving on to the next one. Moving on to the next set of questions. Let's consider these two questions. Find the distance between the points A of -6, -1 and B of -6, 11. So I would say let A of -6, -1 correspond to A of x1, y1, and therefore from this I can conclude that x1 is -6 and y1 is -1. Similarly, let B of -6, 11 correspond to B of x2, y2, which means that x2 is equal to -6 and y2 is equal to 11. Now, according to the distance formula, we get the length AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, and that is going to be under root of, so let's evaluate this now. X2 is -6 minus x1 is also -6, so -6 minus of -6 the whole square plus y2 is 11 minus of y1, which is -1 the whole square. So this becomes under root of -6 positive 6 the whole square plus 11 plus 1, that is 12 square, and therefore this becomes under root of 0 plus 144, which is under root of 144, and that equals 12 units, right? So this is the distance between the points A and B. Now again, let us consider the next question. We have to find the distance between these 2 points. So I will say let A of root 2 minus 1, root 2 plus 1 correspond to A of x1, y1, and therefore I know that x1 is root 2 minus 1 and y1 is root 2 plus 1. Similarly, let B of 3 root 2 plus 2, 3 minus 2 root 2 correspond to B of x2, y2, and therefore I can say that x2 is 3 root 2 plus 2 and y2 is going to be 3 minus 2 root 2. Now the length AB is given by under root of. So now let us be careful. We need to find x2 minus x1 the whole square. So let us first write x2. That's 3 root 2 plus 2 minus, let us write x1. x1 is root 2 minus 1, and then I have the whole square plus y2. y2 is 3 minus 2 root 2, and again I have to subtract y1 from it, that is negative of root 2 plus 1 the whole square. Now we can open the brackets that are there. So I will get this is equal to square root of 3 root 2 plus 2 minus of root 2, minus of minus 1 is plus 1 the whole square, plus 3 minus 2 root 2 minus root 2, and minus of 1 is minus 1 the whole square. So combining the like terms now, let us see if there are any like terms here. We get 2 plus 1 is 3, and 3 root 2 minus root 2 is 2 root 2. So this is 2 root 2 plus 3 the whole square, plus this is 3 minus 1 is 2, and minus 2 root 2 minus root 2 is minus 3 root 2 the whole square. So now I can expand this using a plus b the whole square and a minus b the whole square. So 2 root 2 the whole square. So 2 square is 4, root 2 square is 2, 4 2s are 8, plus 3 square is 9, plus there's going to be a 2ab term. So 2ab term is going to be plus 2 into 3 is 6, 6 into 2 is 12, plus 12 root 2, plus a minus b the whole square. So 2 square is going to be 4, 3 root 2 the whole square. 3 square is 9 and root 2 square is 2, 9 2s are 18, and then there's going to be a minus 2ab term, that's 2 into 2, 4, 4 3s are 12, this is going to be minus 12 root 2. Now you will notice that positive 12 root 2 and negative 12 root 2 cancels, and therefore this becomes 8 plus 9 is 17, 17 plus 4 is 21, and 21 plus 18 is going to be 21 plus 18 is going to be 39, and therefore this distance is under root of 39 units. This is how I can solve this particular question. So let me pause for a minute while you take a look at the solutions, and then we will continue. Moving on to the next question. Let us solve the following two questions. Find the distance between the points R and Q. The coordinates of R and Q are given. So I can say let R of A plus B, comma A minus B be equivalent to R of x1, comma y1, and therefore in this case x1 should be A plus B and x2 should be A minus B. Similarly, let Q of A minus B, comma minus A minus B be equivalent to Q of x2, comma y2, and this implies that sorry, I made a mistake here. This should have been y1, not x2, right? So x1 and y1 are already defined, and now x2 should be equal to A minus B and y2 should be equal to minus A minus B. Now we know that the distance between the points R and Q is given by under root of, we have y2 minus y1 the whole square, or x2 minus x1 the whole square, minus of plus of y2 minus y1 the whole square, and this is therefore equal to square root of, now x2 is A minus B minus x1 is equal to A plus B the whole square, plus y2 is minus A minus B minus y1 is A minus B the whole square, and therefore this is equal to under root of, now if you evaluate this is A minus B minus A minus B the whole square. After opening up the brackets, this is what we get, and over here it is negative A negative B negative A positive B the whole square, right? Now over here A minus A cancels, and in the second bracket B and B cancels, and therefore this becomes under root of negative B is negative 2B the whole square plus negative 2A the whole square, and that is equal to square root of 4B square plus 4A square. 4 can be taken out as common from this, and when you take the square root of it, it becomes 2 under root A square plus B square. So this is the distance between the points R and Q. Pausing for a couple of seconds before taking up the next question. Okay, let us consider the next problem. Km is a straight line of 13 units. So let's draw a diagram. Km is a straight line of 13 units. The coordinates of K are 2, 5 and M has coordinates x, minus 7. We want to find the possible values for x, right? Now it is given that the distance between K and M is 13 units. So I can say that the distance between the points K and M is given by square root of x2 minus x1. Now I can pick any one of these as x2 and x1. So let me do M minus K, that is coordinates of M minus the coordinates of K. So I will get x minus 2 the whole square. The difference in the x coordinates is x minus 2 and square of that. Plus the difference in the y coordinates is negative 7, negative 5, the whole square. This distance is equal to 13. That is what is given to me. So what I did was I applied my distance formula here and I equated the distance to 13 units because that is the distance given to me. Now squaring both sides, what we get is x minus 2 the whole square plus negative 12 the whole square is equal to 13 square, which means x minus 2 the whole square plus 144 is equal to 169, and therefore x minus 2 the whole square is 169 minus 144, and therefore x minus 2 the whole square is equal to 25. And now I can take square root on both sides. So I get x minus 2 is either positive 5 or x minus 2 is equal to negative 5. So I am using the concepts of quadratic equations to solve this particular problem now. And therefore x is equal to 7. We get the value of x is 7, or the value of x is minus 5 plus 2, which is equal to minus 3. Therefore the value of x is either positive 7 or negative 3. So over here now there is a question that can be asked, that can I just open up the brackets in this particular step? So can I just expand x minus 2 the whole square and then can I find the quadratic equation and then solve for x? The answer is yes, you can definitely do that. Though I preferred just leaving x minus 2 the whole square as it is, because I saw that a 25 was coming up and taking the square root is much more convenient on both sides. So this is how I can solve this particular question. Let me again pause for a minute before I move on to the next set. Moving on to the next set. Let us take up the next question. Find the distance between A and B if A is on the x-axis with abscissa 11 and coordinates of B are 7, 3. So let's draw a diagram. The point B has coordinates 7. A is a point on the x-axis. That means I could consider the abscissa of A. Because the point A is on the x-axis, I know that the y-coordinate of A is going to be 0. So I can mention that as the point A is on the x-axis, its y-coordinate is equal to 0, right? And it is given that the abscissa is 11. That means let the point A be A of 11, 0, because the abscissa is 11, right? So the point A is going to be 11, 0. Now we have to find the distance between these 2 points. So I can say let A of 11, 0 correspond to A of x1, y1, and therefore x1 is 11 and y1 is 0. And let B of 7, 3 correspond to B of x2, y2. Therefore, I can say that x2 is 7 and y2 is equal to 3. And therefore, the length of AB is going to be under root of, I can take x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is going to be under root of 7 minus 11 is minus 4 the whole square plus 3 square, that equals square root of negative 4 the whole square is 16 and 3 square is 9, and this is going to be square root of 25, which is equal to 5 units, right? So therefore the length of AB is going to be 5 units. The key to this problem was to identify that because A is on the x-axis, it meant that its y-coordinate is 0 and abscissa refers to its x-coordinate. So this is how I can solve this particular problem, and let me now pause for a minute and we end our today's session here. I hope that you understood the concept of distance formula and how to find distances between any two given points. So pausing for a minute and ending today's session here. Ending today's session here.